So the simplest multiplication case is degree 1, right? X plus 1. And if you multiply this with x plus 2, these are lines with same slope. But when you multiply these two, right, what happens? The thing about multiplication is that the bigger numbers you multiply together, they get even bigger faster, right? The smaller that they are, they become even smaller, right? So this right here, we know that it's a parabola with roots at -1 and -2, which is actually the x-intercept, -1, -2, and the parabola goes like this. Right? So see, it gets bigger, really big. Here, they get really negative, but two negatives multiplied together gives you positive. That's why it goes up like this, which makes sense. That's how multiplication is. What happens if you multiply like x plus 1 with x squared minus 3x minus 4? This is f at x, this is g at x. What would this graph look like? A cubic. I purposely made this factorable, x minus 4 and x plus 1. So this is actually a x plus 1 squared and x minus 4. So with polynomials, it's very easy when you multiply, right? I guess, how about this? So the tougher ones will be something like this. If f at x is equal to 2 to the power of x, we did this example before, and g at x is equal to x, what would that look like? Okay, I'm just going to draw it first. Again, let's just see if we can get a sense of what this would look like just by looking at the pictures. So here's 1. 1 is actually an important number in multiplication. If you multiply any number by 1, it stays the same. But if you actually multiply any number less than 1, it actually gets smaller. But if you multiply any number by bigger than 1, it gets bigger, right? Okay, so it doesn't always grow. What's going to happen is it's actually going to be, so actually here, 1 times 0, it's actually go back to being 0, right? Right? And all of these will shrink. But here we have 1 times 2. 1 times 2, so right, these are called anchor points. This is going to be 0, this is going to stay 1. Fantastic, right? Everything in between, it's going to shrink. Like that, right? Everything afterwards, it's going to actually grow. And it's going to grow a lot. The farther you go, it's going to grow really fast, right? What about after here? Again, -1 is also important. Here's -1. If you multiply this value here by -1, what happens? This particular value right here.
Stays the same.
No, it gets exactly reflected.
Oh yeah.
Right? There's a reflection on the x-axis. In fact, if everything was multiplied by -1, it will be exactly a mirror image like this. Right? It will be. Okay. But obviously, we're going to start from here because it's still 1, right? So what's going to happen in here? Okay, we know that it's going to, at -1, it's going to pass through here, right? So and here, everything is less than 1. Right? It's gonna grow like this towards that, right?
And then it goes down after.
Maybe it will grow something more like this. Okay. And then, okay, all of these small values are multiplied by a big value, right? What happens if you multiply a small value with a big value?
Smaller or bigger.
For example, multiply 0.3 with 10, what happens?
It becomes smaller.
they sort of meet in the middle, right?
Yeah.
Right. If you have, even if you multiply it by 100, but if you multiply by 0.1, you get like 10, right? It meets in the middle, right? Now, what do you think? Do you think this will grow big faster, or this will grow smaller faster?
Go in the middle.
Now, these are y values. There's y values here. They're approaching zero, okay, exponentially. And this is growing really large negatively, okay? And that's also growing. That's growing linearly. So when you, it's kind of a battle of who gets smaller or who gets larger fast. Because even if the number is like 100, if I multiply by 0.000001, this is still going to be really small.
Mm-hmm.
So who's winning the race? Is this getting smaller faster, or is this growing larger faster?
Smaller.
Smaller, because it's an exponential function, right? We learned that the term exponential, grow exponential, is growing way faster than linearly, right? So this is actually gonna do this. It's gonna be sort of here, but it's gonna shrink down. Right? It's gonna in the beginning it gives a fighting chance to the line, but eventually it's just gonna approach the line. So this is the rough picture here. So there you go. All like we just purely did it through logic, right? And our understanding of what grows faster and what doesn't grow as fast. So this is our purely doing through logic, and here's the actual answer.